Yes, sir.
Okay, thank you. Okay, so I think so. I could start now. Okay, so I think so. Now I'm audible as well as the screen is also shared, so I could start now. Okay, I am audible clearly. Just confirm for the last time, so I could start.
Yes, sir.
Okay, thank you very much. Thank you for your patience. Okay, okay, so welcome very much. Very good afternoon, everyone. This is the week 10 of Soil Mechanics Geotechnical Engineering class. And today I'm going to discuss the retaining wall concepts, which is the topic for this week. But as you know, in the last class, we couldn't cover many more things. Many of the questions I have shown you, but due to some health issue, I could not able to cover many points. So I will start from there only. I will cover those concepts as well in this class. Moving forward to the new concept like the retaining wall, we will discuss the retaining wall concepts, how the conceptualization develop, and apart from that, how we could develop the better understanding of the retaining wall things, and that we will discuss. Moving forward, we will cover the problems in the next class. For this class, I have just kept the things like in the previous class, what we have missed out, what we haven't elaborated. I have shown many more things. The questions are also shared with you, but I haven't discussed, so I am not satisfied whether it is well understood by all of you, whoever present over here or maybe afterwards come to YouTube and see the lectures. So I want to show everything over here for once more, and then we will finalize things. Apart from that, my name is Sumit Kumar, and this is the week 10. This is the 12-week series. And if required, I will take one more class like the 13-week series. It could be taken if required. I doesn't assure you, but if I feel that something remain missing, and at the end, I have planned to give you some problems or maybe some concepts or some PDF in the Google document which is already shared with you. In that document, some PDFs may be there which would be helpful for your future reference. Apart from the present courseworks, if you are planning to give some competitive examination like the GATE or the engineering services, that will be helpful. I plan maybe in the due course of time I could not able to give, but I will update the content whatever with me in time to time. So you could keep the that link. That will be very much helpful for all of you. And this instruction is for one and all who are present over here or maybe going to look after these things on the YouTubes later. Okay. And as the general instructions from every class, this class will run for 2 hours. And if due to some any network issue, the call get disconnected, please be remain in the meeting. I will rejoin and then start from there only. Okay. So first of all, what we have discussed during the last class, we will moving in that direction only and covering the things which is left out. First of all, as I remember, we have discussed the conceptualization in that previous class also, and in the previous class we have started with the basic things, basic terminology related to the compressibility, where we have coefficient of recompression, coefficient of compression, volume compressibility, and many more things are there. And I have kept the problems of the GATE examinations as I have mentioned over there, but we could not able to elaborate. So first of all, start with those questions only. Then moving forward, we will discuss the retaining wall concepts in the second shift, that is in the last 1 hour maybe. Okay, so first these questions I have already shared with you, but couldn't discuss in the class, so I am not satisfied. So I will try to cover over here. Okay, so first question is Tarjagi one-dimensional consolidation theory assumes that E is the void ratio and P is the pressure. Relationship is linear. E versus log P, log base when base 10 is log, when base E is log. So option C is clearly eliminated because nothing like those things be there. So option C is eliminated, option D is eliminated, and let me take a pen. Oh, okay. So option C could not be answer. Option C could not be answer. Option D could not be answer because those terms are not there. So only option A and option B remain with us. But if you remember, if you have read, I haven't discussed these things in the previous class. Previous to previous class, we have some gimbals of that. But if you remember, the option A, that E versus P relationship is linear. If you remember, we have discussed some term like CC, CR, and AV. What is AV? As we move forward, you will see AV is delta E, that is change in the void ratio, divided by delta P. While then we have read the coefficient of volume compressibility, that is MV. MV equal to, just I am discussing over here because in coming forward, think some problems related to same will come, and that will be very much important at that point of time. MV equal to AV by 1 plus E naught, where E naught is the initial void ratio, and CC and CR, depending upon it is the compression index or recompression index, each delta E upon log P2 by P1. Maybe at some point of time I could write something wrong, but I feel this thing might be log P1 by P2, but as I recall, T log P2 by P1. So these three terms are very much important because as we move in this class now, we are going to calculate the settlement and some more term like TV. TV equal to CV into T upon T square will be a term where CV T square, where CV where CV is equal to K upon MV into gamma W, and this MV is nothing but MV equal to AV. This MV is equal to AV by 1 plus E naught, MV equal to AV by 1 plus E naught, and AV equal to delta E by delta P. So as we move forward, we will see some problem associated with the same, and where we use TV equal to CV into T by D square, we also see those things. So just a basic thing which I want to discuss over here. So I could move forward. Okay, keep. Okay, no problem. I think you could read from here only. That much thing is sufficient. Option A is the correct answer because Tarjagi assumed that the coefficient of compressibility is constant. Hence, E versus P relationship is linear. Now, now move to the next problem. Over here, it says the coefficient of consolidation, that is CC, is used for establishing the duration of the primary consolidations, establishing the amount of settlement for the load increment, or determining the depth to which the soil is stretched when the load are applied. And the final one is the determination of the pre-consolidation pressure of the soil deposit known to be exist in earlier time, that is to be over consolidated. So for this question, the option number A, option number A or B should be correct. Let me read once again. The question says the coefficient of consolidation is used for establishing the duration of primary consolidation. No, establishment of amount of settlement for a load increment. So option number B will be correct. Next is the true false question, in which it is asked that the 50% of the consolidation at a site subjected to the stress level of 200 kPa occurred in 2 months. If the site had loaded to 400 kilopascal, the 50% of the consolidation would occur in 4 months. Now see, it's a very simple question, very basic question. Suppose uh, let's take an example that you have applied a 1 kilonewton of load to move an object from one place to other place, and it will take t amount of time. So if you applied 2 kilonewton of load, 2 kilonewton, first is 1 kilonewton, now 2 kilonewton of load, to move the that from one place to other place, it will take less time, not more time. That is t by 2 it could take. So basically it is not related in that manner also, but from the common sense also, you could not say that when you increase the load from 200 to 400, the 50% consolidation settlement achievement takes 4 month time. If you apply more stress at that place, it should be like that, it would take less time than earlier. So this is clearly false, and I don't want to go in detail of that, because as we move forward we will solve more problems, and this thing will be clear with you. But this is from the common sense, and these type of problems comes in the many of the competitive examination, and the student uh, don't think crucially, and they will mark the wrong option. So I will suggest that read the question very carefully. Sometimes in question only just you read, you need not to touch the pen, and you would able to answer the question. So the option number, this is the false statement. And the relation which we used, if you remember, in some class I have shown you that for 50% consolidation settlement, TV value is TV equal to CV into T, where CV into T by D square, where T is the time, and this TV is 0.196 for 50% consolidation settlement. For 60% it is 0.283, something like that, as I recall, 283. And for 90% it is like 0.848 or something, 0.848 or something. Just check once. This is there in the table which PDF is I have shared in the last to last class. So just check once. And these are the value, and how we have calculated, we have elaborated over there. But as we move forward in this class only, we will discuss this again and again, because many problems comes on this topic only. That's why I write this formula many times, so that it will remember, it will be remembered by you, so that moving forward you could able to answer the problem associated with the same, right? Now, this is the first statement and how you have understood. So if you go for any examinations, specifically the competitive examination, you see many of the problem doesn't require to touch the pen or to solve anything. Just read the question and answer the question and move forward. Now over here, the next question say the slope of the E log curve for the soil mass gives E log curve give CC value compression index. How? Let me show you. If you remember, if you remember, I have written some in this class only. Sorry, in this class only, I have written CC equal to delta E upon log P2 by P1. When we plot these graphs comes to be linear, but when we plot this in the term of E versus P, this comes to be some arc or maybe some arc of the parabola or something like that curve come. So over here, if you recall the last to last class, over there we have shown the figure as well, in which we have shown that this relations comes to be linear for the uh, uh, for the log curve E versus log curve versus while this linear relations comes to be in the form of arc when we plot E versus P or E versus sigma, whatever you want to say. Right. Now the next question says sand drains are used to reduce the settlement. Okay. Accelerate, accelerate the consolidation, increase the permeability, transfer the load. So if you read this, you could say that it will could lead to reduce the settlement, but whether it is possible that the settlement is reduced, settlement could be reduced due to in the due course of time. uh, it could it could not reduce the settlement. The settlement which going to happen at the specific site due to the characteristics of soil at that place is going to happen. It is not in our hand that we could, because we could not challenge the nature. Yeah, these things are different, that we apply the improvement technique and we will lead to the reduction in the settlement or may add some material from other sites or replace the soil in order to reduce the settlement characteristics. But in its natural state, we couldn't hinder without improving, without proposing any improvement techniques. But that thing is not mentioned. So reduce the settlement, get eliminated. Yeah, accelerate the consolidation, because if you remember in the previous class, I have drawn a figure, a table in which I have shown that the clay layer is there, above that sand layer is there, and below that also the sand layer is there. In that circumstances, the settlement takes place at the faster rate. That means the water flowed out from there at the more pace. But in the same scenario, if you remember, we have also said that if below that clay layer some impervious layer is there and above that clay layer sand layer is there, the consolidation settlement takes place, but time taken by the consolidation settlement get increased. So option B seems to be correct. Now see the option C. Option C so says increase the permeability. You can't increase the permeability of the specific soil in any circumstances, and then transfer the load is not the part of the options only. So so option B is the correct answer. And this elaboration is sufficient and some points are written also. Let me read it for you. That the slow rate of consolidation of saturated clay of the low permeability may accelerated by the means of the vertical sand drains which provide for the radial drainage, resulting in shortening of the drainage path. Consolidations is then mainly due to the horizontal radial drainage, which result in the faster dissipation of the excess pore water pressure. Right now, Now move to the next problem. Okay. This problem I have discussed in the previous class. I tried to discuss, but I could not speak in that class in so fluently. So I feel I could not convey my point. So let me read this question again and let me elaborate the things. So the stress strain behavior of soil as shown in the figure correspond to curve 1. Okay, so over here you see curve 1 is there, curve 2 is there. In the curve 1, the stress and axial strain versus stress is plotted, and in curve 2 you see the progressive movement take place. But for the curve 1 it reaches a specific value, then the axial strain get increased, but the sigma 1 minus sigma 3, that is the shear stress, the parameter which will lead to the value of shear stress remain constant for the increase in the actual strain, or maybe you could say reduced. So over here curve 2 show the normal consolidated NCC, normally consolidated clay. Normally consolidated clay is shown in curve 2, but curve 1 show over consolidated clay. So first you find that what options satisfy. So the normally consolidated clay for curve 2 is written in option C and option D, as I could see over here. Okay, I think so. If you could not able to see the options, let me keep it over here. Over here you can see the in the option C it is written curve 2 is for loose sand and normally consolidated, and curve 2 dense sand and normally consolidated. So while in the option A and option B it is curve 2 is for over consolidated, but not for over consolidated. If it is over consolidated it fails abruptly. So the curve wants to over consolidated. So option C and option D could be our answer. Now the second point is that the whether the dense sand or the loose sand. So again, if it is the normally consolidated progressive failure takes place. Similarly, for the loose sand, progressive failure takes place. For the dense sand, it behave in the manner as the over consolidated clay behave. So the curve one show the dense sand and over consolidated clay, while the curve two show loose sand and normally consolidated clay. So option C will be correct. I think so. I am clear up to this point. Okay. If you have doubt, you could ask, but I feel I am clear. I have discussed this in the previous class as well, but I feel that I could not conclude the point very abruptly in that class. So I have thinking that I could discuss this again. So see, option C is the correct, because again some points are written also. Let me read it for you, that the stress strain curve for the dense sand and the loose sands are similar in shape to the stress strain curve for the over consolidated and normally consolidated clay respectively. Same point is written, and how, why, I have also given the reason for the same. Now you see the next problem say that the time for clay layer to achieve the 90% consolidation is 50 years. The time required to achieve 90% the time required to achieve 90% consolidation if the clay layer were twice as thick, 3 times more permeable, and 4 times more compressible would be. Okay, so the answer I already solved over here. So let me show and discuss, because due to time constant also I don't want to take more time because I have to discuss many things. Otherwise, I will write with the pen and paper and elaborate separately. But if needed, I will write. That's not this. Let me see. So if you remember, I have written this term many a time, that is TV equal to CV into T by D square. Now, over here, the question said that a 90% consolidation. So, if you remember, for the 90% consolidation, the correlation is TB equal to, let me write that thing. Which 10 option is there. If you remember, TB equal to 1.781 0.9332 to 100 minus percent U. If you calculate this, uh, you keep U as 90, this value comes out to be 0.848, as I recall. Okay. Okay. So for the TV is known to us. TV 0.848 is constant. Now the question say that to achieve this 90% consolidation, in the time for the clay layer to achieve 90% consolidation is 15 year. 15 it takes 15 year, that is T 15 year it takes. Now the time required to achieve 90% consolidation if the layer is twice as thick, if D become 2D and 3 times more permeable. So they 3 times more permeable and 4 times more compressible. So okay, I feel something is missing over here because we should relate in this manner. If I am not wrong, we should relate in this manner that TV equal to CV into T by D square. Okay. And then CV, because permeability is also given to CV equal to K upon MV into gamma W into T by D square. And then K upon MV is nothing but AV by 1 plus E naught. So AV 1 plus E naught get cancelled out, gamma W into T by D square. Now you relate, you say that permeability get in each 4 times more permeable and D, if the layer was twice as thick and 3 times more permeable, 4 times more compressible, so AV is 4 times. So in that manner, when you go to solve, the answer comes out to be 80 year only. But that thing you need to understand that in that manner, if you solve it, and that will give you more perfect persona. So I will suggest you this formula will be there. You will solve in that way and you will get the answer as it is here. Or maybe some different. I could not see the answer script, but what I have solved, I think during solution I have missed out these things like the permeability and compressibility. So I will solve and put the answer over there. If I could not able to solve, the question will be there and the formula I have written will be there. So I will suggest you that you will solve using these concepts and you will get the correct answer. Right. Now, see the next question say the consolidation in soil is a function of effective stress. Right? Bilkul, absolutely right. Does not depend on the present stress. It doesn't make sense. It's a function of pore water pressure. If it is a function of effective stress, it is also the function of pore water pressure because pore water pressure could be subtracted and is a function of total stress. So option A is the correct answer over here because effective stress fulfill both the pore water pressure, total stress because total stress minus pore water pressure is the effective stress. So the correct answer is option A, and over here explanation is mentioned herewith that the Terjagi stated that the effective stress controls the behavior of the soil like the compression and the strength. The compression is the function of effective stress. By using the principle of effective stress, Tarjagi derived the consolidation theory for the saturated soil. Right. Now move to the next problem. The next problem say identify the two false statements from the following four statements. The first statement is the consolidation of the soil happened due to change in total stress, effective stress basically. So this is not right in the true sense. When the standard penetration tests are performed in the fines and below the water table, the dilation correction is applied after the overburden correction. Hmm? Maybe the next point is over consolidated clay will have predominantly cohesive strength as compared to the frictional strength. You could say. but the compaction of soil is due to the expulsion of water. So the option 4 is correct, and option 2 is option 1 is correct. Option 1 is correct, that the consolidation of soil happened due to the change in the stress. So the option B is correct over here. Sorry, the option 4 is false and the option 1 is false. Option 2 is correct and option 3 is correct, because when the standard penetration test take place, over there we perform the dilation correction, and in option 3 over concentrated clay will have predominantly the cohesive strength as compared to the frictional strength. Obviously, because in the over concentration clay, what it is there, we have compressed the clay body over there up to such a extent that the stress applied in the present situation is less than the what the stress applied in the prehistorical time at that specific site. So these two statements are correct, and the option 1 and option 4 seems to be false. Now, the next question say the time for a clay layer to achieve 85% consolidation is 10 year. If the layer was half as thick, 10 times more permeable and 4 times more compressible, then the time that would require to achieve the same degree of consolidation is. Okay, no problem. Let's see. Over here, what I have discussed earlier is mentioned in that manner only. Okay. Now see, over here it is mentioned that the time for a clay layer to achieve the 85% consolidation is 10 years. If the layer was half as thick, 10 times more permeable, 4 times more compressible, then the time that would be required to achieve the same degree of consolidation. So as I have mentioned earlier, TB equal to CV into T by D square, and CV equal to K by MB gamma W. If you see this equation, if you see this equation, it is mentioned that K equal to CV into MB gamma W, that is nothing but CV equal to K by MB gamma W. So TB equal to CV into T by H square. If we write CV as K by MB gamma W, then this T is related as H1 square into TV upon K1 into MB1 into gamma W. Now for time T2, that we need to calculate when H2, that is H2 is nothing but 10 times layer is half as thick, half as thick. So H2 is half of H1, and 10 times more permeables. Then K2 by K1 is 10, and 4 times more compressible. So MB2 by MB1 is also 4. So when we have calculated, this comes out to be 1 year. Okay, I think so. What I am discussing for this problem, if you remember, what I am discussing for this problem, this is the repetition of the same thing. I am talking about this only, that is CV equal to T by D square, then CV equal to K by MB gamma W into T by D square, then MV equal to AV by 1 plus E naught, and 1 plus E naught get cancelled out from both numerator and denominator when we equate that, because TV is same for the 90% concentrated at 0.848. So you could able to calculate the thing which is required to answer the problem. Right now, The answer has been presented over there, and now what we are discussing right now is this problem, and the solution is also very much clear for one and all. Now see, the next problem say that a double draining clay layer 6 meter thick settles by 30 mm in 3 years under the influence of certain load. Its final consolidation settlement has been estimated to be 120 mm if a thin layer of sand having the negligible thickness is introduced at a depth of 1.5 meter below the top surface. The final consolidation settlement clay layer will be. Again, this is the similar problem in which the earlier one-way drainage is there. Now the two-way drainage get developed. So the thickness get change. The thickness of the layer get change in that proportion only. So you see the solution which is already there. Um, so it directly written. Okay. It is said, okay, over here it talk about the final settlement. So, what point this question want to develop that the ultimate settlement, if you remember this thing, we have said that percentage u, we have calculated delta, we have calculated tb now. For that we are calculating percentage u, that is nothing but delta h. On the basis of that we are calculating tb, delta h upon delta h. So this delta h remain constant irrespective of anything. And when we calculate small delta h, that is the settlement at a specific time. And if this delta h, small delta h, suppose 20 mm and capital delta h is 100 mm, then the percentage u is 20%, right? So, what point I over here this question asked at the final consolidation settlement. So that final consolidation settlement ultimately going to be capital delta H only, and that remain constant irrespective of the time taken to achieve that consolidation settlement. So that's why the final settlement will not be altered. However, the rate of settlement of clay layer will increase due to the implementation of a sand layer over there. Right. Now see this problem in this. It is asked that a reclamation site uh, for which the soil strata is shown in the figure, a 3 meter thick layer of fill material is to be laid instantaneously on the top surface if the coefficient of volume compressibility MB for clay is 2.2 into 10 to the power minus 4 meter square per kilonewton. The consolidation settlement of the clay layer due to placing of fill material. So let me write the thing which you need to understand, that there is a relation in which we calculate the settlement in total settlement in term of volume compressibility, that is delta H equal to H, the layer of the compressible clay layer, H into MV, small mb, into delta sigma. Right. Over here, at a reclamation site strata shown in the figure 3, which is shown over here. So the compressible layer is clay, which has the thickness of 10 meter. And question says 3 meter thick layer of fill material is laid instantaneously on the top surface if the coefficient of volume compressibility is 2.2 into 10 to the power minus 4. Then the consolidation settlement is there. The fill material is 21 kilonewton per meter cube into 3. So 21 into 3 is 63, the delta sigma, multiplied by 2.2 into 10 to the power minus 4 gives the values in uh, give the values unitless, then multiplied by 10 into 1000 give the total settlement in mm. So see the calculation over here. First of all, delta sigma is calculated. That comes out to be 3 into 21. That is equal to 63. Followed by the relation which we discussed above. That is H naught into MB into delta sigma. That comes out to be 0.1386 multiplied by 1000. That value comes out to be nearly 139 mm of the total settlement achieved using these correlations. Right? Now, uh, let me leave you with this problem. I will suggest you try to solve this problem. Over here, we are taking a very small break of 5 minutes, and we will start again in 5 minutes. Okay, welcome back. So let's start from here. Okay, ठीक है. So okay, so what we are discussing, and that this question is given, and if you have solved this, that question say a 6 meter thick clay layer undergo 90% consolidation, 4 times faster under the two-way drainage as compared to one-way drainage, right? In an identical clay layer of 15-meter thickness, two-way drainage will be faster as compared to one-way drainage by. Okay, so I have the solution for this. Now we have less time, so we will go a little faster. So it say that. Okay, so it is mentioned over here that the time required for any daily consolidation followed Taylor formula, that is dV equal to Cv to T by T square, and uh, as Cv is constant for the same type of soil, so Tv will also remain constant for the same degree of consolidation. So small t, that is time, is proportional to d square, and where d is the length of the drainage path, that is thickness. Hence, in the clay layer of 15-meter thickness, two-way drainage will be 4 times faster as compared to one-way drainage. So option number B is going to be the correct answer. Next question say root time method is used to determine TV time factor, CV coefficient of consolidation, CC coefficient of compressibility, or MB coefficient of volume compressibility. So option number B is the correct answer. That is CV coefficient of consolidation is the root time method is used to determine. Next question is the linked answer question 4.17 and 4.18. Both question is based on this concept only. The 4 point is the figure which is uploaded. It is mentioned that the average effective overburden pressure on the 10-meter thick homogeneous saturated clay layer is 150 kPa. Consolidation test on an undisturbed soil sample taken from the clay layer showed that the void ratio decreased from 0.6 to 0.5 by increasing the stress from 100 to 300 kPa. The initial void ratio of the clay layer is. Okay. So first of all, it is asked in that manner. So over here we are going to use delta E by log P2 by P1, or delta E by the what is given? It is given that the void ratio gets changed from 0.6 to 0.5, and it is asking about the initial void ratio. So over here you could see we calculate Cc as E1 minus E2 divided by log 10 sigma 2 upon sigma 1. Now E1 is 0.6 minus 0.5. Initial void ratio is 0.6 minus 0.5 divided by log 300 minus 2, log 300 by 100. That comes out to be 0.2096. That is the coefficient of compression. Now this Cc value is equated with E1 minus E naught, that is 0.6 minus E naught by log corresponding to 150, that is asked. So log 150 by 100, and the E naught value is calculated at 0.563. Now the second part of the problem is based on this, because it is asked that the total consolidation settlement of the clay layer due to the construction of the structure imposing an additional stress intensity of 200 kPa. So delta sigma is given, and relation we know, delta H equal to Cc into H naught by 1 plus E log base maintenance sigma naught plus delta sigma by its sigma. Delta sigma is known to be 200. Sigma naught at sigma naught of 150, value of E naught is calculated as 0.563. So we use that correlation for the soil thickness of 10 meter, which is mentioned in the first statement of the question, that is the average effective overburden pressure on the 10-meter thick homogeneous saturated clay layer. So this delta H is going to be Cc into H naught by 1 plus E naught log 10 sigma naught plus delta sigma by sigma naught, and that value comes out to be 0.5 meter. Hence the both problem, that is 4.17 and 4.18, get solved. Now the next two problems are over here, which is also depends on one another. One problem is very much easy, second problem is also easy. So let me read this question. The question say the ground condition at a site as shown in the figure, the water table at a site which was initially at the depth of 5 meter below the ground level got permanently lowered to the depth 15 meter below the ground level due to pumping of water over a few years, assuming the following data: unit weight of water as 10, unit weight of sand above the water table as 18 and below as 20, the coefficient of volume compressibility as 0.25 meters square plus by per mega newton, that is MB. So first question asks what is the change in the effective stress in kilonewton per meter square at the mid depth of the clay layer due to the lowering of water table. So the original water table is what is the change in the effective stress in kilonewton per meter square at the middle depth of the layer due to lowering of water table. So as I can see, the initial stress is 5 into 18 plus plus uh, plus 10 into 10 into um, 10 into 20 minus 5, 10 into 15 plus 10 into 2.5. Okay, let me write. Let me write over here so that I could state my say. So for first question say what is the change in the effective stress at mid depth of the clay layer. So mid depth of the clay layer is at this depth. This is 5 meter, and okay, I should not draw over here because later you how you know that what is the thing written over here. Pointer option, eraser. Okay, let me take pen again. Okay, at the middle layer over here. So first of all, in the initial condition, when the original water level is at this level, the stress is 5 multiplied by 18 effective stress plus 20 minus 10. 20 the unit weight below the groundwater table for clay and sand. 20 minus 10 multiplied by 20 minus 5 is 15 plus 2.5, right? If I am wrong at some point of time, please recall, remind me. So this comes to be 90 plus 17.5, 175, 275, 265. This comes down to be 265 earlier. Now later what changes comes? Later it's become 15 multiplied by 18 plus 10, that is 20 minus 10. 10 multiplied by 5 into 2, 5 plus 2.5 means 7.5. So 180 plus 90. 180 plus 90 means 270 plus 75. That comes out to be 345. Right. Now 345 minus 265. 15 into 18 plus 10 into 7.5. 15 into 18 to 70. uh, Plus 75, 345. This difference comes out to be 5 minus 50. 14 minus 680. So this is going to be our answer, that option C. Option C is the correct answer for this. Then second part of the problem say what is the compression of the clay layer in mm due to change in the lowering of water table. So this delta H value is going to be delta H equal to H into mv into delta sigma. Now this H value is nothing but 5. mv is nothing but 0.25. And delta sigma is nothing but 80. So 25 5 is 125. And that is 12.25 5 is 125. 1.25. 1.25 into 80. That comes out to be, let me calculate with my calculator. 1.25 into 80. It is 100. So this value is 100 mm. Okay. So option B is the correct answer. So see, the same is solved over here as well. Delta sigma h comes out to be 80. Then the second part of the problem, the settlement comes out to be 100 mm. Okay. So I feel things are very much clear that I have did the solution over there, and then again if you see the detailed solution, same things comes out to be there. So there will be no confusion in basic understanding of the thing, right? Now we move to our next problem, and next problem say that a saturated clay stratum draining both at the top and bottom undergo the 50% of the concentration in 16 years under the applied load. If the additional drainage layer were present, the 50% consolidation. So again, this is the repetition of the previous earlier solved problem. It takes 1 by 4 time 4 year, as I recall, because same problem, same type of problem is there. So C, B option is correct or not? So B option is correct, and again it use the same concept that T proportional to T square. Over here on the permeability or AB doesn't, there is no dependence has been shown. So that is directly TB remain constant, CV remain constant for the same clay. So T is proportional to D square. As over here D2 get converted to into H by 2 due to presence of a drainage layer. So the T2 also get converted into 1 by 4 times in that proportion. That comes out to be 4 year. Now, now you see the next problem say that a saturated undisturbed sample of clay strata has the moisture content of 22.22% and the specific gravity of 2.7. Assume gamma W equal to 10 and the wide ratio and the saturated unit weight of clay respectively are. So first of all, you use SE equal to GW, and calculate the wide ratio, and that comes out to be S equal to WG. So S is 1, E need to be calculated, G is 2.7 and W is 22.22, that is 0.2222. So E comes out to be 0.6, followed by the second part of the problem say the saturated unit weight. So saturated unit weight is G plus E by 1 plus E into gamma W. G is known, E is calculated, 1 plus E is used, and that comes out to be 22.625. So very simple problem, and no, anyone can solve over here. Now this problem is somewhat interesting. In this, it is asked that using the property of the clay layer derived from the previous questions, which we have solved in 22, the consolidation settlement of the same clay layer under the square footing and neglecting itself with the additional data shown in the figure below, assume the stress distribution as one horizontal, two vertical. So we need to calculate in that order. So over here you see that we have the settlement need to be calculated. Over here you see 200 load is applied, so stress comes out to be and 200 divided by 2 delta sigma. ठीक है. So first of all we have to calculate the thickness at the center of the clay layer. So that comes out to be, basically let me take a pen. This is the center, and over here if thickness is 2, that thickness become B plus 2 N Z. Z is that depth, and N is nothing but one vertical ratio N horizontal. N horizontal. Over here, it is two vertical, one horizontal. So N become 1 by 2. So B plus 2 NZ, N is 1 by 2. And then Z comes out to be 1 meter, 1 meter plus 1.5, that is 1.5. And hence this two get cancelled from this two, and that value become 3.5. And when we divide this 200, because it is square, so 200 upon 3.5 square, it comes out to be 16 or something, that going to be delta sigma. Now you need to, this is delta sigma. Now you need to calculate the sigma. So sigma at that portion comes out to be 18 into okay, so saturated sand and dense sand and clay stiff compression. This layer is so 18 only. So that is calculated over here. You can see that delta sigma is 200 by 3.5 square, and effective stress is 18 minus 10 into 2. 18 minus 10 into 2, right? Plus which we have calculated over here, 20.625. 20.625 minus 10 into 0.5, and that comes out to be 21.31. Now we have calculated overall delta H as 0.4 into 1 by 1 plus 0.6 into log 21.31 plus 16.33 by 21.31. That comes out to be 61.67 mm, right? I think so. Things are very much clear. So both the part of the answer is solved. Now, over here you see E versus log P curve shown in the figure is the representation of it. If it is a curve, if it is not log straight line, then E log P curve must be over consolidated clay. If it is a normal consolidated, this line is need to be linear. Hence, the option B is the correct answer. Let's see, right? I have discussed in detail in this class only in the starting of the class. Now next problem. Again the similar problem in which a drainage layer is applied in the center. 1 by 4 times time get reduced by 1 by 4. What I remember. So let me read the question and the answer you could answer without touching the pen and paper, as we have discussed this problem in 3 more times. So again, the question say basically T is proportional to D square. Identical surcharges are placed at the ground surface at side X and Y with the soil conditions shown alongside. And the water table at the ground surface, the silty clay layer X and the Y are identical. The thin sand layer at Y is continuous and the free draining with the large discharge capacity. If the primary consolidation at X is estimated to complete 36 months, what would be the time required to complete the primary consolidation at Y? Again, the layer is present between them, so time get reduced by 1 by 4 times. So the answer is 9 months. And detailed descriptions of this question is mentioned over here. I will suggest you to look into that if you are have remember and understood the previous two problem. This problem is nothing for all of you. Right. Now, the next question say that a layer of normally consolidated saturated silty clay of 1 meter thickness is subjected to one dimensional consolidation under the under a pressure increment of 20 kPa. The properties of soil are specific gravity 2.7, natural moisture content 45%, and the compression index CC is 0.45, the recompression index is 0.05, and the initial average effective stress is 100 kPa. Assuming the Jayangi theory to be applicable, the primary consolidation settlement. So over here, recompression index and compression index both things mentioned. So what we need to calculate? We have to calculate the total settlement. So I am not going to solve over here. The solution is mentioned over here. Starting with first of all, we have calculated delta HSCC into H0 by 1 plus E naught log sigma naught plus delta sigma by sigma naught, because CR is just a dummy data. And when we calculate it, it comes out to be 16 mm. Very simple problem. Next problem is that in which the sigma naught dash, sigma naught double dash, even E2 both is mentioned, and it is you said to calculate the volume compressibility. That comes out to be AB by 1 plus E naught, and AB is delta E by delta sigma, so 1.1 minus 0.9 divided by 300 minus 175, that is AB divided by 1 plus E naught divided by 1 plus 1.1, and that answer comes out to be MB. So it is calculated in the similar fashion what I have stated orally at this point of time. Now you can see the next problem in which it mentioned that a water tank is constructed on the soil deposit shown in the figure below. A circular footing of diameter 3 meter and the depth 1 meter has been distinguished to take the entire load of 1500 kilonewton. Assume the unit weight of water as 10 kilonewton per meter cube at the load dissipations pattern as two vertical, one horizontal. The expected settlement at the of the tank due to the primary consolidation of the clay layer each. So again, this is the similar problem as which we have discussed earlier. So let me give you the solution and suggest you to do by yourself. It is a very simple problem which we have are repeated over here at this point of time. Next question is again asked that how much it will time take to achieve the consolidation settlement when a 3 meter thick layer is subjected to the initial uniform pore pressure of 145 kPa as shown in the figure. So for the given ground conditions, the time in days required to nearest integer for 90% concentration. So again, we use the same concept Tb equal to Cv into T by D square, where we use Tb as 0.8 and calculated the Tb as 1771 day. The next and the last part of the problem say that the void ratio of soil is 0.55 at an effective normal stress of 40 kPa. The compression index of soil is 0.25. In order to reduce the void ratio to 0.4, an increase in the magnitude of effective normal stress is asked. So again, we use the same relation that delta H equal to H naught into delta E by 1 plus E naught, and we have calculated. We have ultimately calculated the delta sigma as 417.35 kPa. Now, the next problem is regarding the compression curve, and again it's use the same correlation which I have written in the very first slide of this class, in which it is mentioned that the compression curve void ratio E versus the effective stress sigma B dash for a certain clay soil is a straight line in the semi logarithmic plot, and it passes through the point that is E equal to 1.2, sigma B dash equal to 50 kPa and E equal to 0. And sigma V dash equal to 800 kPa. The compression index Cc of against the Cc nothing but delta E by log sigma 2 by sigma 1. So we have calculated that comes out to be 0.4982. So with this, the question part which I want to discuss in this class comes to an end. Now we will move to the some concepts which I want to cover before summing up the today class. So very briefly, we will go step by step and discuss some outcomes which comes in our way during these discussions. Right. So you can see over here that first thing is which we are going over here talking about earth pressure, okay, retaining wall. Right. So let's see what we are going to discuss over here. Give me a minute. See, what we are talking about over here is the retaining wall. And what is the retaining wall and what is with associated with? So it associated with the earth pressure theory, and earth pressure theory become very much important. If you have little bit idea about these topics in which we talk about the earth pressure, so active earth pressure, passive earth pressure, and how it will acting when we in these we take a statement talking about the wall is moving toward the soil, wall is moving away from the soil, and what does it mean and how it conveyed to one and all. So those things which we are interested in over here. So let's see how the things are mentioned over here, and how well I could able to elaborate the things to all of you. Okay, so the first thing is that the retaining wall, and the retaining wall is the earth retaining structures in one way or the other when we're talking in the perspective of soil. So externally stabilized system, soil is not the fundamental part of a system. Gravity wall, typically the small true gravity retaining wall, clip wall, gabion and cantilevered wall. So these are the types of different types of earth retaining structure. In additionally, in situ wall, either the cantilever, braced or the tie back seat pile wall would be there. Then the shoulder pile would be there. Moving ahead, the internally stabilized system soil is the fundamental part of the system. Some examples are the reinforced earth soil nailing. Now, talking about earth pressure, when we move with the earth pressure, we talk about the how the pressure is acting on a wall when the soil is there. So first point is earth why should the earth pressure need to be studied? So it become very much important because the design of foundation wall, basement, safe excavating during the construction and design of the earth retaining structures. So earth pressure type, talking about the earth pressure type, so earth pressure at rest, so the Carnot condition, and over there the earth pressure coefficient is calculated as mu by 1 by 1 minus mu by 1 minus mu, or 1 minus sine phi. And we will move ahead and see those correlations. Then the active earth pressure and the passive earth pressure conditions comes into the reality, comes into understanding. Over here you can see the movement away from the backfill and movement toward the backfill is written in the denominator or the x-axis of the given cable, and you see that the kp value seems to be ultimately higher as compared to the k value that is less than 1 or very less than 1, while the kp value for the others get increased. So the while wall movement required to reach the active pressure. So talking about the different type of soils like the dense sand, the movement is 0.001 h. Afterwards, the soft clay it comes out to be 0.020 h, and the movement of the backfill towards the different direction is mentioned over here. Now, let's consider some active and passive cases. Starting with the active case, when wall moves out, yeah, in active case, wall is moving away from the backfill. In this condition, the shear stress on failure plane get reduces, and the lateral pressure also get reduces. Over here, the minimum lateral stress is achieved when the soil falls and the full strength is over light. Second one is the passive case in which the wall moves in. When it is written that the wall moves in, this means the wall is moved toward the backfill and the shear stress on the failure plane get increases, the lateral earth pressure increases, so the maximum lateral stresses achieves when the soil fails and the strength is mobilized. Right. Now Now we see through the pictorial presentation of these things, starting with the lateral earth pressure at rest. Over there, it is assumed that the sigma h by sigma v comes out to be the k naught, that is the coefficient of lateral earthquake coefficient, and the rigid and static wall friction. So k naught equal to 1 minus sine phi, or k naught equal to mu by 1 minus mu, is the two of the correlations which I have said in very early when I come to know about this thing. Now, over here you see sigma p is the primary while sigma h is the secondary. Next, the Mohr circle at the rest condition is also presented, in which the Mohr circle is not Mohr circle is the pictorial presentation in which it is shown at rest condition, at which the sigma zi is the sigma b dash, while at the second condition the sigma b dash into k naught comes out to be sigma xi. Now you see the lateral earth pressure. Then when the active condition is there, wall is moving away from the backfill, while when the passive pressure condition is there, the wall is moving toward the backfill. So in one way, it's the stress in the horizontal direction is negligible, it gets felt due to the vertical load only, while in the second case it is due to the human prob it is due to the movement of wall toward the backfill. Let's see one by one as we move ahead. First of all, over here the earth pressure and the active earth pressure, passive earth pressure is presented, in which it is moving away from the backfill shown as the active pressure, and moving toward the backfill shown the passive earth pressure. Then the Mohr circle for the active earth pressure condition is presented, in which mm, the Mohr circle is plotted, and the second the failure plane is also emphasized along with. Now, you see in a descriptive manner about the passive earth pressure, in which the in which the retaining wall is moving toward the backfill. Hence, the value of passive earth pressure coefficient get increased, that increase up to uh, 2 to 3 time, or maybe 10 times you can say that if the k is 1 by 3 kp comes out to be 3, and hence the pressure also get increased in the same proportion. Now, talking about the Mohr circle for the passive earth pressure condition, the failure plane and the passive conditions plane should is presented over here. Next one is the active earth pressure. Again, the same graph is presented in the different manner. Let's see the what are the more things which we are going to, I think so these things get repeated. Then we also use some wires to keep the connection so that the failure doesn't take place, and this could lead to the passive conditions in which the earth pressure get mobilized in the term of active and passive. And the jack pressure over there, the 0.65 k gamma h, sometimes of the those correlations are there, that is also known by the very few people. Let's see what are the thing moving ahead. Then the Mohr circle for the passive earth pressure conditions is again shown, and the failure plane and the failure condition is presented. Now it is said that the normal force is applied from downward to upward, and the pp, that is the active thrust, is also presented, while uh, while the this could be explained with the help of example. Suppose that a retaining wall is extended at a specific place to keep the soil body doesn't move toward it, and it get moving away from its initial position. It leads to be some opportunity, or maybe get failure condition differently than that of the active and passive, irrespective of active and passive. Now, You see some assumptions which we take in the earth pressure theory. Okay, give me a minute. Okay. So what I am talking about that some assumptions which we take during the earth pressure theory. So the frictional force between the backfill and the retaining wall are assumed to be negligible. The wall is straight and the surface of the backfill. Basically over here in the earth pressure theory, we see the Rankine theory and Dupit's theory. Okay, let's discuss when it comes. Okay, so the frictional force between the backfill and the retaining wall assumes to be negligible, and the wall is straight and the surface of the backfill is horizontal. The backfill is also homogeneous, granular material is there. These are some assumptions. Then the failure surface is assumed to plane. And these are only assumptions that not always the case. Then some calculations are painted over here based on the picture. I'm not going to discuss over here. These things are important, but not the point of discussion at this point of time. I will directly conclude the things at how we calculate the earth pressure. Let me take a blank slide over here and explain the things for you. Okay, let's see. In the earth pressure theory, one correlation is there that if this is the retaining wall, we just draw a simple uh, like this, and the stress acting comes out to be 1 by 2 into K A gamma Z or H, whatever you consider. Square. That is the stress acting at this force. And that is the stress acting in this portion, and it is acting at h by 3 from the bottom. So that what we have calculated. And how we calculate? We simply calculated the stress. We draw the effective stress diagram and we multiply the K value in that. Subsequently, we normally when we calculate the earth pressure at any depth, we type write K gamma z. Okay, but if cohesion is there, then the Dupuit's theory comes into action, and over there we write K gamma z plus, sorry, minus 2c root K for the active state, while this become K gamma z plus 2c root K. Okay, so these are the only two things which we use, and the derivation of the same I am not going to discuss at this point of time. Now you will see, uh, now you see over here that what I want to show, that we have considered the soil body at a specific depth h. On that, stress is acting in the horizontal stress is the sigma 3, while the vertical stress at that specific sections comes out to be gamma h, because that gamma is the soil density and h is the depth, and subsequently those discussions are there, and I don't think these are any point of discussion. Huh. But one thing become important. What is K? Basically, K is, if you see K naught at one point of time, K is sigma h by sigma v, and this K value comes out to be 1 minus sine phi upon, you will see the derivation at once by yourself, or the third discussion. I am not interested in that because that is not very much important. I am really interested in concept. And 1 by sine phi by 1 plus sine phi, or cot square 45 plus 5 by 2. Similarly, uh, kp is 1 plus 1 plus sine phi upon 1 minus sine phi. Right. So these things are there, through which we calculate K and Kp. And this Kp could also be written as tan square 45 plus 5 by 2, and what it angle make with one another is also some point of disconnection at a different point interval. So those things are also there. Now the more circle discussion is there, which is just need for derivation. Now what I have mentioned earlier, that it act at h by 3 from the bottom, and what it has shown over there, that it act from 2h by 3 from the top. That is the same thing, and that value comes out to be 1 by 2 into k into gamma h square, which we have mentioned in a separate slide. That is same thing is mentioned, that it comes out to be 1 by 2 into k into gamma h square. Basically, we are calculating the area of Earth's pressure, which has been drawn over here. Subsequently, if the water tables comes there, as you recall, the effective stress diagram get transformed due to the presence of water table. Similarly, the earth pressure stress diagram also get transformed, and the K value is not multiplied for the water turn, but it doesn't get subtracted. So over there you see, in the let me take a pointer to show more precisely. Over here you see it is written that K into gamma K into H1 into gamma T, that is the gamma T is the unit weight over here. Over here it is gamma dash, we calculated as gamma T minus gamma W. So we multiplied this that K only because the soil characteristics is same. C and 5 value are they same there. 5 value is if same, then the 1 minus sin 5 or plus sin 5 also remain constant. So over here we also do multiply K into H1 into gamma T, that is the top section, plus K into gamma H2 into gamma dash. But why we had subtracted the gamma W and then we calculated this value. But one thing needed to be understood over here, that we have added H into gamma W for these sections. We doesn't remove H into gamma W because the stress is there due to H into gamma W at that point of section, and only the earth pressure coefficient for the water is not multiplied. Now the question could be asked, why K is not multiplied? Because the stress applied at a specific section due to water body is in equilibrium from the all directions, so no need for that calculations. That's why we have eliminated. Now, okay. Now you see some more point related to the earth pressure. First is the cohesionless backfill and the inclined surface. Okay, so as we are discussing up to that, we have talked about the cohesionless backfill. But in one slide where I explained the thing, I have mentioned that for the cohesive soil, the Dupuit's give its theory in which he had added 2c gamma root k plus for the passive earth pressure condition while subtracted for the active earth pressure condition. Now see what things are here. So first of all, you see over here it is mentioned that it is mentioned that the cohesionless backfill and the inclined surface. Let us consider a cohesionless mass with a sloping surface behind the smooth vertical retaining wall. The lateral stress acting on the vertical face of the element are parallel to the inclined surface. Thus, any such planes experience not only the normal but also the shear stresses. Needless to say that they are no longer principal planes as was the case for the horizontal surface. Now, talking about the corresponding resultant pressure on the wall could be determined with the aid of Mohr circle. The magnitude of the vertical stress is depicted by the distance OC, and the lateral stress acting parallel to the sloped surface is represented by the distance OA, sigma h equal to OA. Okay, so these things and the explanation is mentioned for this discussion. Now we will move to some other part in which the inclined backfill is also there. Over there, the question also arise that for the inclined backfill, the coefficient of earth pressure is active earth pressure is cos I or cos beta, whatever you say, cos I minus cos square I minus cos square phi, and cos I plus root into cos square I minus cos square phi. Similarly, for the passive, it get reversed. The numerator become plus and denominator become minus. And in the same fashion, we could able to calculate the passive earth pressure acting at the specific section. Now, so same things are mentioned over here again and again. So I feel with this, we come up to the end of the today's session. So I think so over here we will end up the today's session, and some questions related to the today's session will be taken in the subsequent classes, right? Okay, so with this I will sum up the today class. Thank you for joining. Rian. Uh, I will see you in the next class. Next class will be the 11th class. Over there, we are going to discuss the questions on the retaining wall and some more concepts which would be more helpful for all of you. So, thank you everyone for joining. Wish you a very happy weekend. Thank you. Now I am
Thank you, sir.
ending the
Thank you
today
so
class.
much.